Pleasant day, STEM learners. This is Sir Peter, your Precalculus teacher. So this video lesson is intended to you to acquire more skills regarding the standard equation of the circle. So this video lesson was intended for you to find the center and the radius given the standard equation of the circle and vice versa. So given the first example, we are required to find the center and the radius of the circle. So obviously, this example takes the form x squared plus y squared is equal to r squared. This is when the center is at the origin and our r is, of course, we get the square root of 900 because this is our r squared. So the answer is 30. So all you need to do is to determine the coordinates of the center and the radius. Let's have the second example. So suppose you were given examples like that. So you need to simplify first this equation by dividing both sides by 4. Okay, so dividing both sides by 4. So what will happen? What is 4x squared divided by 4? Of course, it's x squared. Then 4y squared divided by 4 is y squared. But what's the value of 196 divided by 4? So obviously that is 49. Okay, and since this is 49, then we get the square root of 49, so we'll get r is equal to 7. But still, our center is located at the origin, or 0, 0. Let's move to the next example. So let's again find the center and the radius given this standard equation. So obviously, this example now takes the form the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. So we have to give the opposite of the signs to determine the center. So obviously, our center is at 2, -4. Don't forget to invert the signs, okay, when you write them in the coordinates of the center for your h and k respectively. And how do we get 3 the square root of 5? We simply get or simplify the square root of 45. And that is the square root of 9 times 5. And the square root of 9 is 3. That's why our r is 3 the square root of 5. Notice that the next example is very tricky because the y minus part is written first before the x minus part. So all you need to do is also reconsider the arrangement of the standard equation. So your center should be at 1 and -3. So always be careful in thinking about the arrangement first of our standard equation because we refer to it as h and k now for the center. And of course, to get 6 square root of 3, which is our r here, we simply get the square root of 108. And we can rewrite it actually as 36 times 3, and the square root of 36 is 6. And then the remaining radicand is the square root of 3. So I hope you understand. Let's proceed to the next skill. What if we do the other thing or the vice versa? Suppose that we have a given standard equation of the circle. It's really easy to find the center and the radius, but let's do the other thing in which we need to give the standard equation given these conditions. So we have center at the origin, r is equal to 24. Of course, we will use the formula x squared plus y squared is equal to r squared. So By that, our answer should be x squared plus y squared, and then we square 24, and the answer will be 576. Okay, I hope you understand. Let's move to the second example. What if our center is at 0, 7 and r is 25? So take note of this one. The 0 of CISA is translated as x squared only, while 7 is translated as the quantity y minus 7 squared. But many would mistakenly write 5 here as the answer. But what we need to do here is to square 25 instead. So sometimes you might mistakenly get the square root of 25 and then your final answer will be 5 here. But in this case, you have to square 25. So don't get confused about squaring, because in the formula, this requires an r squared. So many students have common errors in answering this problem because they get the square root of 25 instead of squaring 25. Suppose we have this given. The center is at negative 7, 0, r is 5. So we translate our h value as the quantity x plus 7 squared. And then the 0 will be translated as y squared, simply y squared. Then we square 5, so that's 25. You see the difference of the previous r? The previous r is 25, and it is squared as 625. While in here, it's just very simple, it's 5. So we square it as 25. So the other problem is a tricky problem. There are also instances that it's only the k and the h which are given. And in this case, our r is a radical sign. So the answer here is you have to articulate first your h value. So it becomes the quantity x minus h squared, and the k value, that's y, the quantity y plus 9 squared. And then to get 63, we have to square the entire radical. So it becomes 3 squared, and we have the square root of 7 squared. So 3 squared is 9, and then we cancel the square root and the square value. So that becomes 9 times 7. And 9 times 7 is 63. Sometimes you will also encounter such problems in which you have to illustrate first the figure. So let us assume that we are graphing the center at 4, 3, 4, negative 2. So this is where the center is located at quadrant 4. So suppose that it is tangent to the y-axis. So we assume that the circle has r here. So the distance is actually r equals 4. So when we create the circle, we imagine that this circle is tangent to the y-axis. So it's very important that we know r, the value of r. So if r is 4, r is equal to 4, then we can rewrite the equation as what equation? It's the quantity x minus 4 squared plus the quantity y plus 2 squared is equal to 60. Okay, let's move now to the next problem. The center is at 4, negative 2 tangent to the x. The equation of the line x is equal to 6. So obviously, we need to graph again. 1, 2, 3, 4, then negative 2 here. So this is your center. And since it is tangent to x is equal to 6, that line is represented by this vertical line. So this is your x equals 6. And since this is the center, so it will touch that. So this will be your circle, okay? then your r here is obviously 2. So since you have a center with r2, then the standard equation will be the quantity x minus 4 squared plus the quantity y plus 2 squared is equal to r squared, which is 4. So I hope you will be careful in answering problems like that. So this is the end of my supplemental video lesson regarding the skills involving or the competencies that you will be needing involving circles. Good day and God bless. Again, this is Sir Peter, your pre-calculus teacher.